All right, welcome back. In today's video lecture, we're going to talk about measures of central tendency and measures of variation. So we'll start with measures of central tendency. You've certainly heard of these before. We've got the mean, the median, and the mode. Those are the most three common of the measures of central tendency. And I'm sure you probably know how to find them. We'll go through one really simple example of how to find them. And then we'll talk about when to use them, because that's actually quite a bit more important. So let's look at an example. Let's say we've got the numbers 1, 3, 4, 4, 4, 5, 6, 7, 8, and 8. All right, so let's find each of those things. Let's find the mean, the median, and the mode. All right, so the mean is generally what you probably think of when you hear the word average, although really each of these is an average. Average is just a typical value, and so we can use any of these three things to mean the typical value of a data set. But each of them are just a one-number summary of a set of numbers. So in this case, we've only got 10 numbers, but if we've got 1,000 numbers, to be able to get any sort of sense of what's going on with the data, it's helpful to summarize the numbers. All right, so the first way to summarize numbers is to find the mean. And to do that, we just add up all the numbers and divide by how many there are. So if we add up these 10 numbers, we get 50. And then if we divide by how many of them there are, 10, we get the mean is 5. The median is the middle number when the numbers are in numerical order. That's important. So they do have to be in numerical order, and then we pick the middle number, which in this case, there isn't a middle number because we have 10 numbers, so that's an even number. If we have an odd number of numbers, then the median will be the number in the middle. Otherwise, we just average the numbers on either side of the middle. So in this case, the 4 and the 5. So we'll do 4 plus 5 divided by 2. Our median is 4.5. The mode is the number that occurs most often. So in this case, that's 4, because 4 occurs 3 times. 8 occurs just twice. So our mode is 4. Mean and median, there are always just one of each of those. Mode, there can be no mode. So if every number occurs just once, there is no mode. And then we can have multiple modes. So if we had another 8, then we would have 2 modes, 4 and 8. Or we can have infinitely many modes. So anyway, we can have more than one mode, but always just one mean and one median. All right, now let's talk about real quick when each of these is relevant, because it's not always. So for example, the mode is for numeric data, which is probably what you're used to finding the mode of. It's generally not very useful. The mode is most useful for categorical data. So for example, if I asked everyone in my class, what's your favorite color? Well, I can't find the mean of that. I can't find the median of that. But I can still summarize it by saying, okay, maybe blue is the most common favorite color. And so that would be the mode. It's just the most common value. On a test, the mode doesn't really make much sense, typically, because, for example, on our tests, I think MyLabs Plus rounds to 2 decimal places. So the chances of anyone getting the same test score are really small. So the mode is probably 100 most of the time, just because a couple people get that. But otherwise, the mode it's really just not that meaningful. The mean is meaningful so long as you don't have any outliers. Outliers are values that are either much higher or much lower than the typical value. And when that happens, that can throw off the mean. So for example, if I found the average amount of money all of us have in our checking account, that would tell us something. But then if we added in Alice Walton, from Walton Family, Walmart, Fortune, If I added her in and I found the average that all of us had, it would make us look like we're all millionaires. So that wouldn't be a very meaningful average. Median is really good when you have data like that, where you have outliers, because the median just picks the value in the middle. So if you watch the news and you hear them talking about the economy, and you hear them talking about wages in the country, you'll hear them talk about the median wages or the median home price, for example. They don't give the mean because that can be highly influenced by outliers. So instead, they talk about the median. So while you may know how to calculate these numbers before this class, and I'm sure you probably did, it's really helpful to know when to use these numbers, because when you get out into the real world and get a job, it's important to know if one of these numbers is more useful than one of the others. So don't always just give the mean when you're trying to summarize things. Think about, well, sometimes the median might be a better choice. All right. So one of the things that you learned in the pre-class assignment video or learning assignment video, if you're in my online class, is how to find the mean in the calculator. And so you can type all of this into the calculator and you can find the mean in the median as well. The mode is not something that the calculator gives you, but it's something that's pretty easy to pick out. Another thing you learned was how to find the mean of grouped data or interval data. And so we'll do an example like that real quick. We won't use the calculator, but you can watch the video to see how to do it in the calculator. So let's say we've got some intervals. And let's say these are test scores. So we've got some people between 50 and 59, some people between 60 and 69, some people between 70 and 79, some between 80 and 89, and then some between 90 and 99. So on this test, no one got 100, and no one got below a 50. So then we've got the frequency. The frequency is how many people fit into that interval. So let's say we had 2 people in the 50 to 59 interval, 14 in the 60 to 69, 24 in the 70 to 79, 18 in the 80 to 89, and 7 in the 90 to 99. Now, to find the mean here, we have to make an assumption, and that is that each of the values occurs at the midpoint of the interval, because we have no idea what any of these scores are. The two test scores between 50 and 59, they could both be 50s, or they could both be 59s. We have no idea. But we have to make an assumption, and our best guess is that they're right in the middle. So we'll call this the midpoint, which I'll just write as MP. And the midpoint is we just add the two numbers together and divide by 2. So, for example, we would add 50 plus 59 and divide by 2, and that's going to give us 54.5. So that's our midpoint for that interval. 60 to 69, add those two together, divide by 2, that's going to give us 64.5. 70 plus 79, divide that by 2, we're going to get 74.5, and so forth and so on. 84.5 for the next interval and 94.5 for the last interval. All right, so those are our midpoints. So what we're assuming now is that every test score is one of those 5 test scores. So the two that were between 50 and 59, we're assuming both of those are 54.5. So now to take the average, essentially we're just going to add these all up. We're going to add up 2 54.5s. We're going to add up 14 64.5s. We're going to add up 24 74.5s, and so forth and so on. Now we could actually type that into the calculator one at a time, 54.5 plus 54.5 plus 64.5, 14 times. But it would be a lot easier just to use what we know about multiplication, which is that multiplication is just a repeated addition. So if we multiply our midpoints times our frequencies, then that's the same as adding them up. So 54.5 times those two scores, that's 109. 64.5 times those 14 scores, 903. 74.5 times those 24 scores, 1,788. 84.5 times 18, 1,521. And then 94.5 times 7, 661.5. All right, so then we want to add up all the frequencies to figure out how many students there were. In this case, that's 65. And then we want to add up all the midpoints times the frequencies, because that's going to be the total of all the test points. So that's going to be 4,985.5. So then to find our average, all we have to do is divide those two numbers. So 4,985.5, total of all the test points, so that's all the test points added up, divided by how many tests were taken, 65, and that gives us an average of about 76.65, rounded to 2 decimal places. So that would be the average test score. Okay. All right. So again, we could do that in our calculator. All you have to do is put the midpoints into list 1, frequencies into list 2, and then the calculator will do the rest of the work for you. But this is how we would do it by hand. All right. The next thing we're going to talk about is measures of variation or measures of dispersion. So measures of variation or dispersion is about how spread out the data are. Now, this is really important right now. I'm recording this video in spring of 2020. I might use this in future semesters, but right now, the coronavirus is kind of a big deal and is why I'm recording these videos. But you've probably seen graphs and charts talking about flattening the curve. And so the idea here is that the number, so each x value would represent the number of days, and then the y value is the number of people with the coronavirus on each given day. And so what we're trying to do by flattening the curve, that's the social distancing of trying to spread out the number of people who have the disease at the same time, because the capacity for the healthcare system is, I don't know, maybe somewhere around there, and we don't like this. That's where people are sick and there's no hospital beds. We don't want that at all. So that sort of distribution right there is very... the dispersion is very small, so everything's close together, which means that there are an awfully lot of people with the disease at the same time. Whereas the flattened curve distribution is we're spreading it out. So the number of people who have the disease is probably going to be the same, but we're spreading it out over a longer time period, so the number of people who have it per day is smaller. And so that spreads it out. That allows the healthcare system to do its job. So anyway, the whole idea here, so this is important in this scenario, but is also important in business and lots of other things. It's good to know how spread out your distribution is. So the mean can give you a really good number, a really good one-number summary of what's going on, but it doesn't tell you about how spread out things are. So let's talk about a couple different measures of variation that we have. First, we've got the range. And the range is the maximum versus the minimum. So we just take the highest value minus the lowest value. That can be helpful if there aren't any outliers. If there are outliers, then that can really obscure what kind of the more typical range is. Another measure of dispersion is variance, which is a pretty difficult number to interpret because the units are squared, which makes it kind of awkward to interpret. We'll talk about it more here in a little bit. But it's really important in statistics. So if you take a statistics course or if you have taken a statistics course, you'll likely talk about a test called ANOVA, which is analysis of variance. And so it's a really important number. It's going to help us find another number. And so we'll go over that here in just a minute. But that number that it will help us find is standard deviation. And standard deviation, this isn't a formal book definition, but just to kind of give you an idea of approximately what it is, it's essentially the average distance from the mean. So if we look at each value in the distribution and say, okay, how far are each of these from the mean? If they're far away from the mean, then the standard deviation is larger. If they're closer to the mean, the standard deviation is smaller. And so let's kind of look at an example that'll kind of help us see that. So let's say I gave a test to just 4 people. And let's say those scores were 70, 70, 70, and 70. So the average of those scores, which we write as an X with a bar on it, is 70, right? Add those 4 scores up, divide by 4, we get 70. The average, or the average distance from the mean is 0, because each of those points is the mean. So the average distance from the mean is 0. But I could also give a test. Let's say we got 2 40s and 2 100s. That also has a mean of 70, but it's a very different outcome. If I gave a test like that, I would be very unhappy. That would mean that some of my students really got it, and some of my students did not get it at all. So that's a very bad outcome, but it looks like the same outcome as everybody getting a 70. And so that's why standard deviation is really important. The mean doesn't tell us the whole story. So down here, where we had 2 40s and 2 100s, the average distance from the mean is 30, because each of those points, 40 and 100, are 30 points from the mean. Now, that's not exactly what standard deviation is. We'll look at how to calculate standard deviation, but that's just kind of a general idea of what standard deviation is trying to find. So next, we're going to look at how to find standard deviation. Now, just like the mean, you can find the standard deviation using the calculator. You can put all the values into list 1, use the 1var_stat button, and find your standard deviation. And it's similar with interval data as well. But we're going to look at real quick how to find standard deviation. It won't take too long, and I think it's important to see how it actually works. So let's assume we've got 10 test scores. They are 61, 82, 76, 93, 99, 57, 78, 76, 86, and 72. So we want to find the standard deviation. So that is kind of on average, how far away from the mean are these data points? So the first thing we need to know is, what is the mean? So if we add up all of these data points, all 10 of them, we get 780. And if we divide that by 10, we get the mean as 78. Okay? So we're trying to find the average distance from the mean. So the next thing we want to do is literally just find how far away from the mean are each of these points. So we're going to do 61 minus 78 to find its distance from the mean, 82 minus 78 to find its distance from the mean, 76 minus 78 to find its distance from the mean, and so forth and so on. So we're going to call that column x minus x bar, because x bar is the mean. So all we did was take each of those values minus 78, so minus the mean. And that gives us negative 17, 4, negative 2, 15, 21, negative 21, 0, negative 2, 8, and negative 6. So that's how far each of those values, each of those 10 test scores, are from the mean. Now, all we're trying to do here is find the average of that. We want to find the average distance of the mean, and we have all of the distances from the mean. So let's add those up, divide by 10, except that when we do that, we're going to get 0 just by adding up all of those values. And that's because that's how the mean works. With the mean, you always have the same number of points below the mean as above the mean. And so when we're looking at the distances here, the negative distances always end up balancing out with the positive distances. So we need to do something else in between. So what we're going to do, it may seem a little weird, but to get around this, the fact that when we add these up, we get 0, what we're going to do instead is we're going to square all these values, and then we're going to find the average, because the squared values will all be positive. So I realize that seems a little weird, but that's what we're going to do. All right, so let's square all those values. So we'll write those in another column, x minus the mean squared. So we square all those values, we get 289, 16, 4, 225, 441, 441, 0, 4, 64, and 36. So instead, we're going to find the sum of all of those values and then find the average of it. So if we add up all the values in that column, so the squared distances from the mean, we get 1,520. All right, so let's take our 1,520. So that's the sum of all the test points. So we're finding the average here. So the average squared distance from the mean. All right, so 1,520, and there's 10 values. Now, we're going to do something else that's a little weird. This is because we have a sample of data. So we only have 10 test scores. Likely there were a lot more test scores. And so when you don't have everything, you have what we call a sample. And when that is the case, we have to have a correction factor. So we actually subtract 1 from the number of data points. We don't really need to worry about that too much for this class, other than we need to do it to actually find the standard deviation. So we're going to take 1,520, divide that by 1 less than the number of data points that there are. But again, essentially what we're trying to do is find an average. All right, so we're going to divide that by 9, and we're going to get about 168.89. All right, so that is the average or approximate average of the squared distance from the mean. All right, so what does that tell us? Well, the average of the squared distance, that's a really hard number to interpret. And so earlier I mentioned something called variance. And that's what this number is. It is the squared distance from the mean, which is not that helpful because it's not in test points. It's in test points squared. So that's not super helpful. So what we're going to do is, since we squared all of our values, we're going to go in the opposite direction. We're going to take the square root of our variance. So square root of 168.89, and that's going to give us about 13.00. So what this tells us is that on average, when we look at these test values, on average, the test values are about 13 points away from the mean, which we figured out the mean was 78. So that's what our standard deviation can tell us. On average, how far away from the mean are the data points? In this case, the answer is 13. All right, so what can we do with that? Well, let's draw some distributions. So this is what we're going to be talking about in the next section. This is a normal distribution. You've probably seen something like this before. In fact, I drew one of these earlier. On the normal distribution, we have the mean in the middle. So mean is x bar, and that is 78. And then we also have our standard deviation. Our standard deviation is S sub x, and it's about 13. All right. So the way a normal distribution works is one standard deviation goes, in this case, 13 points in either direction. So one standard deviation of the mean is from one standard deviation below the mean, that's 13 points below 78, and that's 65, to one standard deviation above the mean, which is 13 points above 78, that's 91. And so that right there, we would say is one standard deviation of the mean, 1 S sub x. And within that range is going to be about 68% of our data. So that's a general rule of thumb. It's likely not exactly true for our data, but it should be pretty close if the data is normally distributed. I'll show you how to find this 68% number next time when we look at the normal distribution. But before we do that, let's go back to our original data and let's see how many actually fall within this range. So the range of 65 to 91. All right, so looking at our data, 82 is within the range of 65 to 91, as is 76. Let's see, the next couple aren't. So 61's not, 93's not, 99, 57, those aren't within that range. 78 is, 76 is, 86, and 72. All of those are within that range of one standard deviation between 65 and 91. And so that's how many of them? That's 1, 2, 3, 4, 5, 6. So in this case, 6 out of the 10 or 60% of our data points lie within one standard deviation. And that's something that you'll be asked to do on some homework problems, is just count what percentage of your data points fall within one standard deviation. And so again, how to do that? You just take your mean, add your standard deviation to get to one standard deviation above the mean, subtract your standard deviation to get to one standard deviation below the mean. We can also do this, we can continue to go farther away from the mean. So 2 standard deviations above the mean would be another 13. So that would go all the way up to 104. So that's 13 points above 91. And then all the way down to 52. And so that's 13 points below 65. So that, anything within that range, that's 2 standard deviations. So 2 S sub x. And in general, that's going to be 95% of our data. It's actually going to end up being 100% of our data if we go back and look here. Every one of those data points is between 52 and 104. So all of ours are. But in general, the general rule of thumb is 95%. So we'll talk much more about the normal distribution next time. But that's our video on measures of central tendency, the mean, median, and mode, and then measures of variation or measures of dispersion, which were range, variance, and standard deviation. All right, I'll see you next time.